Today what we're going to do is we're going to practice writing chemical formulas and names for ionic compounds that do not have a transition metal in them. So what we first need to do, an ionic compound has a cation and an anion. We're going to need to know the predictable charges on the periodic table, which are called oxidation numbers. Group 1 have +1, group 2 is +2, group 13 is +3, group 14 is plus or -4, group number 15, -3, -2 for 16, and -1 for 17. We're going to use that information as we go through, so I just wanted to make sure that I had my periodic table labeled and ready to go. Now your ionic compounds have a metal or a cation, which are all your positive charges over here, and an anion, which are all your negative charges over here. You can also have polyatomic ions. Your polyatomic ions are mainly all anions, but you do have that one positive cation, which is ammonium. So if we start with something simple like BAS, we have Ba, which is barium, and S, which is sulfur. When we write the name of this compound, your cation name always stays the same no matter what. So Ba, we said, is barium, so we're just going to write down barium. And then S is an anion. For your anion here, what we're going to do is we're going to change the last part of that name to end with IDE to show that it's paired up with barium. So sulfur is going to become sulfide. So when we write the name of BAS, that's just called barium sulfide. Now if we do another example, this one has a number in it, that 2 right there. That number doesn't mean anything in the naming process other than the fact that we have 2 of these potassiums and we just have 1 oxygen. So when we're writing the name of this formula, we're not going to do anything with that 2. So I just told you that K is potassium, so you're going to write down potassium. Your potassium, your cations, they always stay the same, so we're not going to change the name of that first element. The second element, you're going to change the ending to end with IDE for your anion. So oxygen is going to become oxide. So the name of this formula is just called potassium oxide. Now this next one has a polyatomic ion with it. With your polyatomic ions, a lot of times we put them in parentheses here to show that we have more than one of that polyatomic ion. But again, we're going to disregard all of the numbers. So Al is my cation. Al is aluminum. So I just write out the word aluminum. And then CO3, -2, which is now canceled out. That CO3 is called carbonate. So I'm just going to write out carbonate. You cannot change the name or the formula of a polyatomic ion, so whatever's written on your paper, you're going to keep it that same name. So this is just called aluminum carbonate. Now this next one, you have CSOH. This OH here is actually a polyatomic ion. It's just not written in parentheses because there's only one of them. So you could write it in parentheses like this, but usually we don't like to, only because it's unnecessary. So we're going to do the same process that we've been doing. Your cation name is going to stay the same. It's cesium. And then OH for that polyatomic ion, that's called hydroxide. So the name of this formula is just called cesium hydroxide. So those are fairly straightforward. What we're going to do next is we have the name of something and we're going to write the formula. Now with this I will need my periodic table that I have numbered. I have lithium sulfide. My lithium is a metal. Lithium lives right here on the periodic table. It has a +1 oxidation number. So I'm going to write down Li, and it's +1. And then my sulfide here, my sulfide is actually sulfur as an anion. So I'm going to find sulfur on the periodic table. Sulfur has a -2 charge. And then once I have my cation and my anion, I swap and drop those charges, which if you don't know how to swap and drop, you can see my other video on Dr. Gable explains swap and drop. But my plus and my minus disappear. This 2 is going to travel over here, so you actually make Li2S. Now to do another one, this one is called calcium carbide. Calcium, for your metal, it lives in group number 2 right here. You have Ca plus 2, because all of group 2 have a plus 2 oxidation number. Carbide, IDE, it is carbon on the periodic table. Carbon's a nonmetal, so it has a -4 charge. So we're going to swap and drop with that one. My plus and my minus disappear. This 2 travels over here, the 4 goes over here, so it makes Ca4C2. But my 4 and my 2 are both divisible by the same number, which is 2. So I need to reduce this one down. 4 divided by 2 is 2. 2 divided by 2 is 1. So that's going to give me Ca2C for my final product. Now this next one has a polyatomic ion with it. So on this one I've got lithium back again. Lithium lives right here. It has a +1 charge. Bicarbonate ends in ATE. So it's usually a trigger for us to know that we need a polyatomic ion. This is one of them that we memorized in class, or you can look it up on your polyatomic ion chart. Bicarbonate, when you look it up, is HCO3 -1. So we need to swap and drop again. The plus and the minus disappear, so you end up with a 1 and a 1. So when you write this out, it's just going to be LiHCO3. You can put this in parentheses if you want to for your HCO3, but we only have one of them, so that's really all that you have to do. For the last one, I have magnesium nitrate. Magnesium is right here on the periodic table in group 2. It has a +2 oxidation number, Mg +2. Nitrate, ATE, tells me that I have a polyatomic ion. My polyatomic ion is NO3 -1. So again, I'm going to swap and drop. My plus and my minus disappear. This 2 is going to travel over here. Because I have more than one nitrate, I'm going to have to put my NO3 in parentheses. The 1 would come over here, which is just stays the 1. So when I write this formula, you end up with Mg, NO3 in parentheses, and a 2 outside. So this tells me that I have 2 of these nitrates and 1 magnesium.